To understand our impact on Earth, we first have to think about Earth as four interconnected parts, or systems. The geosphere is everything solid: the rocks, the soil, and the core of the planet. The hydrosphere is all the water, from the vast oceans to the tiny drops of rain. The atmosphere is the air that surrounds us. And finally, the biosphere is where all living things, including us, exist. These four spheres are constantly interacting, like gears in a giant machine. As humans, we are just one species within the biosphere, but our actions have become powerful enough to influence all the other systems. Think about what you need every day. You breathe air, atmosphere, drink water, hydrosphere, eat food grown in soil, geosphere, and build homes on land, geosphere. Our reliance on these resources means that everything we do, from turning on a light switch to buying a new pair of shoes, causes a ripple effect that touches all four spheres. In science, we always look for cause and effect. When we talk about human impact, the cause is a human activity, and the effect is the change it creates in an Earth system. It's like a line of dominoes. For example, when a town decides to build a new shopping mall, the cause is the construction. The effect is that the land underneath is covered by concrete, affecting the geosphere, and rainwater flows differently, affecting the hydrosphere. Every action has consequences we need to investigate. The geosphere, or the land itself, is dramatically changed by human use. Imagine looking down on Earth from space. You'd see huge patches cleared for agriculture to grow our food, and massive cities built with concrete and steel. We also have to dig into the ground through mining to get the metals and minerals we need for our devices. These activities physically change the landscape, leading to the destruction of habitats and permanently altering the Earth's surface structure. One big problem tied to the geosphere is soil erosion. When we clear forests or natural grasslands to build farms or houses, we take away the plants whose roots held the soil in place. Without that natural anchor, when the wind blows or the rain falls, the topsoil, the most valuable, nutrient-rich layer, is easily washed or blown away. Losing that fertile soil makes it much harder for us to grow crops in the future, creating a cycle of negative impact. Water is essential, and our demand for it puts huge stress on the hydrosphere. We are constantly withdrawing water from natural sources. Farmers use massive amounts for irrigation. Factories use it for cooling, and of course, cities need it for drinking and sanitation. When we pump water out of aquifers, those huge underground rock layers that hold water, faster than rain can refill them, the groundwater levels drop. This can dry up rivers and wells, and even cause the ground to sink. Beyond just using up water, we also add things back in that don't belong. Pollution. One major example is when farmers use too much fertilizer on their fields. When it rains, the excess chemicals run off into rivers and lakes. This extra food for the tiny organisms in the water causes something called an algal bloom, which can use up all the oxygen and create dead zones where fish and other life can't survive. And of course, the plastic trash that ends up in our oceans is a massive threat to all marine life. When you think of the atmosphere, you should think of the air we breathe and the air that helps regulate Earth's temperature. Our biggest impact on this system comes from burning fossil fuels. That's the coal, oil, and natural gas we use to power almost everything. When these are burned, they release gases like carbon dioxide, CO2. This gas traps heat in the atmosphere, leading to what we know as the enhanced greenhouse effect and climate change. The burning of fossil fuels also creates more immediate, localized problems like air pollution. Think about the thick, brownish haze you sometimes see hanging over a big city. That's often smog. It's a mix of smoke and fog, full of tiny, harmful particles and chemicals released by cars and industry. This kind of pollution directly affects our health, especially our lungs, and also harms plant life, and can even damage buildings. The biosphere is the realm of life, and human activity has been its greatest challenge. When we clear huge forests or drain wetlands to build roads and homes, we are destroying natural habitats. Imagine a bear's forest is cut in half by a highway. Now it has less room to hunt and can't safely get to its family. This fragmentation and destruction of habitats is causing a huge, rapid loss of biodiversity, meaning we are losing plant and animal species at an alarming rate. Humans also affect the biosphere through overconsumption. We are taking resources faster than nature can regenerate them. The classic example is overfishing in the ocean. Modern fishing technology allows huge ships to catch so many fish that the remaining population can't reproduce quickly enough to replace them. Similarly, allowing too many cows or sheep to eat the same patch of grass, overgrazing, can turn healthy grassland into a dry, desert-like area. Remember, the four systems are always talking to each other, and action in one system immediately affects the others. For example, the sulfur and nitrogen chemicals released into the air, atmosphere, from factories can mix with clouds to form acid rain. That acid rain then falls into the lakes and forests, hydrosphere and biosphere, damaging trees and killing fish. This is a perfect example of how one human cause creates consequences across all four systems. A key part of the human impact story is our use of non-renewable resources. These are things like oil, coal, and copper that were formed over millions of years through slow geologic processes. Since it takes so long to form them, they are considered non-renewable on a human timescale. Once we use them up, they're gone forever. Our modern society relies heavily on these limited resources, which is why we need to plan carefully for the future. One of the core ideas in this standard is that natural resources are distributed unevenly around the globe. This unevenness is the result of millions of years of geologic processes, like volcanoes and plate movements, which concentrated certain minerals in specific locations. However, human activity, specifically our widespread removal and consumption, is rapidly changing that natural distribution. We are essentially scooping up these concentrated pockets of resources. Let's construct a scientific explanation for mining's impact. The evidence is simple. We dig massive pits and tunnels to extract mineral ores like gold or iron. The impact is that we permanently remove the concentrated pocket of that resource from that location. The explanation is that by removing resources formed over geologic time, we are changing the geosphere's natural composition and the local distribution of minerals forever. The same kind of explanation applies to groundwater. We see evidence of human activity when cities or farms pump water from deep underground aquifers. The impact is that the water table drops, sometimes causing the ground above to sink. The explanation is that we are accessing water that has accumulated over centuries and are draining the supply faster than rain and snowmelt can naturally recharge the hydrosphere's reserves. Our impact is also influenced by two numbers: the global human population and per capita consumption. More people mean more need for resources. Per capita consumption is just a fancy term for how much stuff one person uses, like how many cars they own, how much food they waste, or how many flights they take. As both the total number of people and the amount each person consumes increase, the negative impacts on Earth systems grow exponentially. When you're asked to construct a scientific explanation, you need to be precise. You start with a claim. For example, human activity harms the biosphere. Then you back it up with evidence. For example, satellite images show rapid deforestation. Finally, you provide the reasoning to connect the two. For example, deforestation removes essential habitats, causing a measurable loss of species. This clear structure is how we scientifically communicate human impact. It's important to remember that humans are also capable of positive impacts. We have the ability to solve the problems we create. Actions like reforestation, planting trees to rebuild forests, help the biosphere and pull CO2 from the atmosphere. Switching to renewable energy like wind and solar reduces our reliance on fossil fuels. And simply recycling and conserving water helps slow down the rate at which we deplete the geosphere's and hydrosphere's resources. The big lesson here is sustainability. This means meeting our needs today, drinking, eating, building, powering our world, without compromising the ability of future generations to meet theirs. By understanding the cause and effect relationship between human activity and Earth systems, we can use science and engineering to develop smarter, less impactful technologies. Our goal isn't to stop living, but to live in a way that keeps all four Earth systems healthy and balanced for the long run.